algebra students. Let's take a little look at sets. A set is a many that allows itself to be thought of as a one. Georg Cantor. So Georg Cantor, if you remember, is the gentleman who had the quote, "The rationals are the stars in the night sky, and the irrationals are the black." Spectacular sets. We're going to have some vocabulary and a lot of notation. A set is a collection of objects. An element is a member of the set, and the symbol for element is the Greek letter epsilon. A set is usually named by capital letter. We have different methods of describing our sets, and this is where the notation will come in. We have roster notation, set builder notation, interval notation, number lines, and Venn diagrams. Of these, you will probably like interval notation. You will dislike set builder notation. So let's see what these look like. Roster is where we just list the elements of a set. Roster is where we list the elements of a set within the curly brackets, and we separate each element by a comma. So if we think an example would be A is the set of all even numbers from 2 to 10, then A would be equal to curly bracket 2, 4, 6, 8, 10. B is the set of all positive integers, so B would begin with 1, 0 is neither positive nor negative, and we use the ellipsis to represent that it goes on and on. We could put ... and we could put the infinity symbol and then the curly bracket. Either of those would be correct. The order in which the elements of a set appear within the braces does not matter. If S is the set of the first 3 lowercase letters of the alphabet, then ABC is equal to BCA, and that is equal to CAB, etc. So order doesn't matter. If A is equal to 2, 4, 6, 8, 10, then the way we would write 4 as an element of A would be using that Greek letter epsilon. Also, if I used a slash through the epsilon, then that would mean 3 is not an element of A. I'd like you to pause the video here and take a look at each of those 3 sets. If you're back with me, the first set matches to C, the second set to A, and the third set to B. Now, a subset is a set contained within another set, and the symbol for that is kind of like a sideways C that's stretched out. If A is the set 1, 2, 3, 4, 5, and B is the set 2, 4, then we would say B is a subset of A. You can think of it kind of as contained in, right? Because it's kind of like a C. B is contained within A. Okay, here we go. Set builder notation. So this is a little fancy, and some of you will not like it very much. You do have to use the curly brackets. They don't have to be perfect, but they do have to be curly brackets. We use set builder notation when we cannot list using roster form. Example 1. Now what this says in words is the set of all x. This vertical line means such that x is an integer. The second example, it's saying R is a set that contains x. Also, the colon means such that. The set of all x such that x is a real number greater than 2. This R is in the set of real numbers. And we'll look at some other ways of saying that. Okay, so let's practice a little bit with set notation. So you can pause here, look at examples 1 and 2, and write in words what those 2 sets say. Okay, number 1 is going to say the set A is all x in the set of real numbers such that x is greater than or equal to 7 and less than or equal to 11. So that's a lot of words to write out, which is why we have this fancy notation to make it a little easier. The second one says x is an element of the integers such that x is greater than or equal to 2 and less than 6. Now what I'd like you to do is pause and complete the rest of the page using set builder notation. Okay, number 3, the set of all real numbers that are less than 4. So I use the curly brackets. X is an element of the reals such that x is less than 4. So if you think here after seeing that you might have misrepresented your answers, pause and go back and correct them. 4, the set of all real numbers greater than -3 and less than or equal to 5. Number 5, the set of all real numbers greater than -1. And we should be getting the hang of it. So if you want to take a look at the rest of the page and see how you did, we will move on. If c is equal to y such that y is less than -2 and y is an integer, then which set would be a subset of c? Yes, that is number 3, choice C. And which set represents the set of non-negative real numbers? Non-negative would be choice B. 0 is not negative. We didn't say it was positive, we just said it wasn't negative. And then we end our day with a little comic on greater than and less than symbols.